Hello everyone, this is Preeti from Hanna Instruments. So this is your uh, webinar for troubleshooting guide to pH electrode. I would like to inform you all that this is a recorded webinar. For any queries or any questions, you can mail us at application@hannains.in, and for inquiries, mail us at marketing@hannains.in. So, pH electrode is one of the most uh, important unit of a pH meter, which comes in contact with the sample, which which is the key to measure pH of your sample. And pH is one of the most important parameter that defines the quality of your product, or even sometimes many things are dependent on pH measurements like solubility of some solutes, then quality parameters, then understanding the condition of condition of the sample is dependent on the pH. So it is very much, you can say, very much necessary to measure pH very effectively, and also it is very important to measure it correctly. So to measure pH correctly without any hurdles, it is necessary to have a very efficient pH electrode. Yes, of course, a pH electrode is efficient when you select a correct pH electrode for your samples according to your samples. But this subject is for next webinar, or this is for another webinar we're going to be discussing for. But this is very important. Whichever pH electrode you use, you should be able to maintain it, you should be able to store it, and if time comes, you have to be able to troubleshoot as well, so that your pH measurement is hurdle free, and you can consume the maximum life of a pH electrode. So what are the very common problems that people face for any pH measurement or with an electrode? Most common problem that we face is we see very drift in a reading, or we see erratic reading. Drift means never ending drift, means you might see continuous increase in the pH measurement or continuous decrease in pH measurement, or there is high fluctuation in the reading. That cause can be an erratic reading, can be observed at the time of measurement. So, what are the possible factors that give drift in measurements or erratic readings during measurements? The most common possible uh, possible error can be contamination of the sensing glass. And yes, the contamination of sensing glass is a very common problem. The common problem that can be faced by a user if he is continuously using a pH electrode with many samples, and the sample get deposited on the electrode. Although if you see the electrode bulb is clean, but it doesn't mean it is clean. It might have a very slight error of the deposition layer of the samples on the bulb of the pH electrode. So why contamination gives erratic readings? Contamination might give erratic readings, or might give wrong readings, or might give readings higher or lower as slightly lower, slightly higher than expected, because it the the deposition of the samples or any other material on the electrode, the millivolts of that deposition adds on to the millivolt of your sample, might give positive or negative interferences in your reading. Thus, thus the solution or the troubleshoot to this common issue is to clean your electrode regularly with cleaning solution. Whenever you calibrate a pH electrode, The meter itself assumes that the electrode is clean, and thus it nullifies the error after the calibration accordingly. Thus it is very much necessary that you should have a clean electrode just before calibration. So you can follow a protocol that you have to clean your electrode with the cleaning solution after you complete your measurements. At the end of the day, when you have completed all the pH measurements, just keep your electrode in cleaning solution for say 10 minutes period of time according to the cleaning solution that you are using. Then clean your electrode with the DM water, and then you store our electrode for overnight period of time in the storage solution, and then the very next day your electrode is ready for calibration and for the measurements. Then another unidentified problem is clogged junction. Many people do not understand whether the junction is clogged or not, mainly when they are using a ceramic junction or they are using a clogged junction electrode. Ceramic junction is very susceptible to get clogged when you have high contamination in your sample and you have high conductivity in your sample. Ceramic junction as well as the clogged junction. Other junctions like a sleeve junction or open junction or even Teflon junction are very have very low susceptibility to get clogged. But if your junction gets clogged, you might see a very slow response, very drift in the reading because the reference junction, so that as the reference junction is clogged, the reference electrode doesn't come in contact with the sample, thus the electrode will not have a stability in pH measurement. Thus, a junction can be removed by keeping your electrode in the cleaning solution in 0.1 normal HCl at slightly elevated temperature also, and then cleaning with the DM water and then storing your electrode in the storage solution. This will um, clean the clog of the ceramic junction. But if it's a clogged junction, you just have to pull out the one-fifth part of the affected part of the clogged junction, cut the clogged part of the clogged junction, and uh, the pull out the junction that in the removed junction will be exposed to the samples. Thus, you will get a very high response in the measurement. So, depending on the sample, clogging the electrode uses and the clogging of the electrode use electrodes that are specific to your samples. Like you have separate electrodes for wastewater samples, you can have a separate electrode for normal water samples, and etc. Another most common problem people might face is due drift in the reading is maybe due to they have low conductive samples. Yes, low conductive samples will like DM water or RO water will never give a stable reading in matter of time. Yes, you have to wait for a long period of time to get stable electrode, which might eventually ruin your electrode as DM water is very reducing tendency and it will leach the silica, it will uh, leach out the uh, reference electrolyte from the reference junction as well and thus ruining your electrode completely. Thus, we have to make sure that you add a small amount of high purity potassium chloride into your sample to increase the conductivity of your sample, and then you measure pH of your sample. Thus, this will not only give an accurate pH but also will not ruin your electrode completely. Secondly, then not storing electrode properly can also give drift drift or erratic readings. Yeah, storing electrode uh, in storage solution is very much recommended. It will The storage solution will build a hydrated layer on the bulk of the electrode. Thus, you will get stability in readings as the diffusion of hydrogen ions will be limited according to the pH of your sample. Then some external noise or interferences also might cause drift in the reading. So you just have to take a representative sample, move away from the noise due to rectifiers or motors or pumps, anything, and then you have to check the pH of your sample in order to get accurate and approximate pH measurements. Then inaccurate readings are also observed so many times in the pH measurement. So what are the possible problems? A major possible problem can be wiping of pH electrode with tissue. Yes. Wiping or rubbing the pH electrode with tissue paper can cause static energy to develop on the hydrated layer and the bulk of the electrode, thus giving positive or negative interferences in the reading, and thus it might also scratch the surface of the junction or the surface of the pH bulb. Thus, it might give highly inaccurate readings. Thus, in this case, you just have to stop using the tissue paper to clean your electrode. Instead, use a DM water to clean your electrode and then store your electrode in the storage solution. If you still think that it is not getting cleaned properly, you can use cleaning solution daily after ending your measurements, and then you can store your electrode, and then you can use calibration or pH measurements. The improper calibration also can give inaccurate readings in pH measurement. Inaccurate calibration means you might use a buffer which is contaminated or which is not giving proper millivolt as expected or as according to the theoretical value. At that time, you might get an improper calibration an improper calibration can lead to inaccurate readings because calibration is not only uh, done to nullify the errors due to regular use or any manufacturing defect or attack of the sample, temperature, and anything else, but also it is calibrated in order to get proper readings. So, if calibrate properly, the millivolts generated can be related properly to the calibration graph and thus will get proper reading, approximately proper reading. Thus, improper calibration can lead to highly inaccurate readings. Calibrating and measuring at different temperatures. Calibrating if your buffers have different temperature and your electrode or your meter is at different temperatures, then the temperature probe will calculate the pH according to the temperature. Thus, it might, if your 4 buffer is at 15 degrees centigrade and if your 7 pH buffer is at 20 degrees centigrade, then the difference of 5 degrees centigrade will create an error in the in the calibration, and thus will either will not take the calibration or will have some errors in the calibration, giving out inaccurate readings. Then you have to make sure either you use a pH meter with ATC feature in it, or you use all the pH buffers at similar temperatures with in consideration with your meter. Then, if you observe frozen readings. Frozen readings means if you observe a particular reading like 6.47 or 5.8 or 7.0 and 7.89 any of the buffers. It might be 6.1.68 or 7.0 or 4.0 and 12.45. If you have a similar or frozen reading in all the buffers in all the sample, then there is a possibility that your internal electrode is broken internally. Yes, it is a possible chance of having a crack or a break in sensing glass, thus giving a frozen or you can say similar readings in all the samples. This is the time that you have to replace your electrode with a new one. Then how to calculate slope and offset? Offset is nothing but the millivolt readings of 7 of the pH buffer 7.01 taken at 25 degrees centigrade. So this is the offset value. This is very much important that you should always note an offset and slope values after calibration in order to keep your electrode and your buffers into observation and always this will make sure that you always use fresh and accurate buffers for accurate calibration. If the slope value at 25 degrees centigrade is 59.16 millivolts per pH. It means that if you switch from 1 pH to 2 pH or from 3 pH to 4 pH or from 6 pH to 7 pH, the millivolt difference at 25 degrees centigrade must be theoretically equal to 59.16, but it of course have an acceptance window or acceptance criteria of plus minus 4 millivolts. Thus, after calibration, if you observe a slope of 100%, it means per millivolt change is 59.16. But if you observe the slope of say 90%, it means it is somewhere around 56 or 57 per millivolt change per pH at 25 degrees centigrade. So as slope drops, the slope value also drops, and as slope increases, the slope value also increases. You have to keep the slope value or the slope percentage into observation every time after calibration of your meter. Not only slope values but also offset values. Offset, if you have high offset values like 30 millivolts or 40 millivolts, you have to either clean your electrode or you have to either replace your buffer. If your electrode is taking is taking a high amount of time to get calibrated and your meter is not accepting the calibration, then at this time either you have to change your buffers or your electrode. If to verify whether you have to change your electrode or the buffers, you just have to verify whether your buffers are giving proper millivolts or not. So there are every buffer have a particular millivolt, and according to this millivolts, the electrodes are calibrated. You just have to verify by testing the millivolts of the buffer whether the buffers are fresh or not, and then you will understand whether there is an issue in your buffers or the issue is in your electrode. So if you could see on your screen that slope percentage calculation, if you could see there is two examples of two electrodes, electrode 1 and electrode 2. Electrode 1 is calibrated at 7 and 0 and similar result electrode 2. But electrode 1 is giving out a good slope of 98%, whereas an electrode 2 is giving out a very bad slope of 82%, which is not into acceptance criteria. Then why the slope have dropped in electrode 2? Because if you could see the difference between the absolute millivolts of electrode 1 is somewhere around 175. That is somewhere around the acceptance criteria when you go from 7 pH to 4 pH. It is theoretically 177 and observed is 175. So only 2 millivolt difference is into acceptance criteria. Whereas if you see into electrode 2, The difference is very high from 145 to 147. Hence, the electrode slope has dropped completely and is not correct electrode. So, to troubleshoot second electrode, you might have to replace pH 4 buffer or you have to replace electrode completely. So it depends upon the millivolts of your buffers. So electrode lifespan is also a very important factor everyone should have into consideration. So if you have continuous testing at elevated temperatures like 70 degrees, 80 degrees, 90 degrees or 85 degrees, you might observe that the electrode lifespan is very small. Yes, so if you observe, if you have continuous measurements at ambient temperature or at room temperature of 25 degrees centigrade, you might consume a maximum lifetime of the pH electrode, which is 2 years. Yes, you have to accept that the maximum lifetime of a pH electrode is maximum 2 years if you store, maintain and clean your electrode properly and you continuously measure at 25 degrees centigrade. And according to general rule, if you if you if there is any increase in the temperature at the time of measurement, so every 25-degree increase will reduce the life of pH electrode by half. Thus, if you have complete measurements at say 90 degrees or 95 degrees, you might observe the electrode lifespan is only of 1 month or so. Why? Because electrodes do not respond correctly after continuously in getting exposed to high temperatures. And then another highly misconception people have is storing pH electrode in purified water. Yes, this is the very biggest misconception people have. Yes, storing pH electrode in DI water can cause an osmotic effect. It will the the highly concentrated salt solutions of which is filled in reference compartment will leach out into the DI water stored in the storage cap of the electrode and thus reducing or changing the concentration of reference electrolyte as well as of the storage solution and will ruin your electrode bulb and junction completely. Thus, the electrode will no more longer will be in use. So you have to store your electrode in storage solution only and not in the item. So for any questions, you can mail us at application@hannainstruments.in and for inquiries, you can mail us at marketing@hannainstruments.in. Thank you for attending the webinar.